Hi, everybody. This is Jamie at WDTD. I want to welcome you to the Warning Decision Storm of the Month for January 2017. Holy cow. Strategies for managing a difficult combination, mixed precipitation, flooding, and it's a holiday weekend. This is presented to you by Jamie Morrow and Steve Caton from the Blacksburg, Virginia office. Next slide, please.
Thanks, Jamie. Beautiful mixed sun and cloud day here in Blacksburg, so hopefully you guys are seeing similar weather to what we're seeing. I'm here with Steve Caton, the Sioux from the Blacksburg forecast office. He'll be around, especially during the question and answer session. And we'd love to get your input on some of this stuff, especially if you have other ways around it, or if you're interested in some of the aspects that we have done during this event, we'd be happy to share those with you. So as Jamie mentioned, we're going to be going over some of the lessons learned from the February 14th through 16th, 2016 President's Day East Coast snow, ice, and rainstorm that we saw here, and many of those in the Mid-Atlantic saw during that season. And for us, it's actually a very important event to pay attention to. However, with such a busy weather year last year, it's often an overlooked event. This was sandwiched between the major blizzard on the East Coast between January 22nd and 23rd, where we got over a foot of snow across most of our forecast area, with a peak of 30 inches or more just west of the District of Columbia in Sterling, CWA. But also we had a very significant severe outbreak about a week later. The February 24th event actually produced a never-before-seen EF3 tornado in Appomattox, Virginia, the first of its kind, at least in the month of February in our forecast area, and other deadly tornadoes just to our east in the WFO Wakefield forecast area. Going back to this event, it was a multifaceted event. We had record cold in place. As the precip came into our area, we saw a mix of snow, sleet, freezing rain, wind on the backside, with even flooding when it came to the runoff, and several days after, when it finally got to the rivers, we saw some minor to moderate flooding in a lot of our rivers. And we'll go over most of this stuff, but it also was a big event for much of the East Coast with the tornado outbreak across the southeast U.S. states, including an EF3 in Florida. So it certainly was an outperforming event, and just to look at what we'll be going through during this presentation, we'll go through the meteorology portion, kind of go through an overview, get some precipitation-type challenges, especially when it came to the cold air damming event that was in place, some of the impacts, both of the event meteorologically, but also on the staff, which caused some issues in the area. We'll go over some of the tools that we found to be useful during the event, the communication techniques that were used, including social media, how we presented briefings to our partners and the public, and then, of course, the way we were able to ensure that we had proper staffing in place, especially with an event that came situated around a holiday weekend. We're here to share some of the lessons that we learned, how we overcame some of the obstacles that we were faced, but we love your feedback as we continue on through the event. For those of you who are not familiar with our forecast area, the Blacksburg CWA is nestled in the Mid-Atlantic part of the United States. We do have the Appalachian Mountains that run through the western portion of our forecast area. The eastern slopes of the Blue Ridge are present here. And it's a very complex area to forecast for, both meteorologically, but also when it comes to some of the amount of states, for instance, that we have to forecast for. We have 3 in our forecast area. We go through a large chunk of Southwest Virginia, parts of Southeast West Virginia, and a few counties along the border of Virginia and North Carolina, including some pretty interesting terrain features down there. And the terrain in our forecast area is one of the most challenging aspects. We go from anywhere of 5,000 plus foot peaks in parts of the Grayson Highlands of Virginia and parts of Northwest North Carolina, all the way to around 400-foot elevations in the Piedmont of Virginia and North Carolina. So quite the discrepancy there. We have 2 different winter storm criterias. For the west, we have 5-inch and 24-hour periods for the higher elevations that are a little bit more used to some significant snowfall events, where in the east, it only takes about 4 inches in 12 hours to hit that criteria. So keeping those in mind, it's also a very complex area to forecast for. A few sites I want you to pay attention to as we go out through the event. We have 2 upper air stations right here in Blacksburg where our office is situated, notified by the red balloon here, and also a site just to the south of our forecast area in Greensboro, North Carolina, which is very beneficial, especially when it comes to some of the impacts and effects that we feel toward the east in the Piedmont region. Looking at some SREF sites, we have Blacksburg once again where our office is located, and the city of Danville. We'll be taking a look at some of the forecast plumes out there. All right, so we'll start off just looking at some of the synoptic features that this event entailed. As I mentioned before, we have a high pressure in place across much of the northeast U.S. states. This high was a very strong high and actually brought enough cold air in to break several records across the mid-Atlantic region and the northeast U.S. states while this was in place. As the first wave of precip impacts parts of our area, that high really begins to intensify and actually wedge down the eastern slopes of the Appalachians. You can really see the cold air starting to dig in as the rain starts to impact our area. And of course, at this point, this is all snow, and we'll go into a little bit further details with some soundings a bit later on. As the high moves out, that wedge remains in place, and the low really begins to strengthen across the Gulf Coast states and ride the spine of the Appalachians to the north, from the southwest to the northeast. With this type of pattern, we really have issues when it comes to P-type changes, especially with the wedge in place. Another pattern we often see is this low will actually track just to the east and strengthen across the Atlantic seaboard here. When that's the case, it's pretty easy forecast when it comes to which precipitation type you would see. With all the cold air mixing in, it's mostly snow. But with the warm air advection once again reestablishing, we have that quick turnover just as some of the heaviest rain is pushing through, and it really causes our forecasters some headaches as this is going through. So looking at some of the where the high confidence was in the event, well, our forecasting confidence in the fact that moisture was going to be present was high. It really wasn't a question of how much. It really wasn't a question of would the moisture be in place, but rather in what form and what precipitation type will that moisture fall? Will it be in the snow? How fast will there be changeover to sleet? And that would really play into some of our totals. So looking at the SREF plumes for the Blacksburg forecast area, this is a little bit more complex terrain here. First, looking at the precipitation type probabilities, you got snow represented in blue. It looks like it was pretty prominent that snow is going to start off the event. A brief changeover to sleet indicated by the pink color was going to take place with a quick transition into some freezing rain and then finally ending the event with some rain. We were pretty high in that the fact that we would see at least those 4 types of precipitation types. However, the exact transitions, there were certainly some differences when it came to the model output. Looking at the forecast snow amounts here in the bottom of the screen, you can see there's a pretty wide spread. There was certainly some uncertainty when it came to exactly how much was going to fall. You saw anywhere from near 0 amounts to up to 10 inches in the Blacksburg for the Blacksburg site. Obviously, there's a pretty good clustering in that 6 to 8 inch range where that normal or that average line is sitting. And if you get rid of some of these outliers, that's probably right. It would actually probably be notched up a little bit. So we certainly started to see some clustering as the event came closer, but it was certainly still very uncertain on how long that would remain snow before that transition. That's not the case here in Danville. Danville is a little bit farther east in the Piedmont counties, and we're really seeing, we were highly uncertain on exactly when those precipitation type changeovers were going to take place. Our confidence was much lower, but the one thing we did know is snow wasn't going to be as much of a factor, and most models did agree. You had a couple that came up here to give it 9 to 10 inches, but we were pretty quick to realize those are outliers, and that really set us between the 1 to 2, maybe up to 3 inch if it hits the high side range, at least for the Danville area and parts east in the Piedmont counties where that changeover was going to occur faster. Here's some of the this is the snow accumulation forecast just before the event started to begin. You'll see that we really went with higher totals out west, where that colder air was going to be in place a bit longer, 6 to 8 for the Blacksburg area. As you head a little bit further west, you even saw some 8 to 12 in parts of the high country of southeast West Virginia. Where we were higher confident of not seeing as much of an impact in snow, you really see those lower totals. And these stayed pretty low throughout much of the event in that 1 to 3 inch range, maybe touching on 4 inches just as the event was getting underway. Ice was certainly a concern in this event, and most of the area was forecast to see quite a bit, up to a 1/4 inch in some spots, especially up here in the Monongahela National Forest of Greenbrier County and a few other areas. Especially as you go east, you're seeing higher impacts, at least at a wider spread type point of view, but we were certainly concerned with some of the impacts that this much ice, 0.1 to up to a 1/4 inch of ice could have in the forecast area. All right, so this is a kind of a complex graphic, so I'll try to describe it here. Top left, we'll see the upper air sounding for Blacksburg area. We have the Greensboro, North Carolina in the bottom left. You have the reflectivity, and then we used MPING as more of a ground truthing type citizen science look at things to see exactly when those changeovers were reported using some of the citizen scientists out there. So as we step through the event, you'll see the initial overrunning wave of moisture. Looking at the soundings, you certainly had cold enough temperatures and a saturated profile that was well to your atypical snow soundings. A bit of dry air as that precip was at the surface as that precip was moving out of Greensboro, but you still saw a temperature of 25 at the surface. Plenty cold enough with the saturation through the best levels here to see snow in most of these areas. As that low begins to strengthen over the southeast U.S. states, you really saw those temperatures in the warm nose, especially at the 850 millibar level, start to creep between that or up to that freezing point, just to overcome it, as the precip was light here, but the little pockets that did form saw a lot of sleet, especially in the Piedmont counties of Virginia. And you'll start to see that changeover, especially to the south and east in parts of Raleigh's forecast area here in North Carolina. As the main wave of precip approaches, that warm nose gets much more prominent here in the Greensboro area, and you even see it start to touch above freezing here in Blacksburg, with surface temperatures well below freezing in both parts, 29 in Greensboro and 24 in Blacksburg. So you're still seeing cold enough temperatures at the surface to get that ice accretion, but it's not falling as totally snow anymore. You likely saw a changeover to sleet, which is being represented here in the MPING data. As we move along, you'll see the main wave of precip come in. We actually had reports of some wind damage as this line kind of pushes through the southern portion of our forecast area and continued on east into Raleigh, CWA, in parts of eastern North Carolina there. As you can see, right at the 12Z sounding the next morning on the 16th, you really saw the temperatures finally get above freezing just as the rain was moving out in Greensboro, and again here in Blacksburg, where we're sitting right at 33 degrees. All right, so let's look at some of the impacts. The storm total snowfall, as you can see, we had mainly that 6 to 8 inch range in the higher elevations, which correlated pretty well with that final forecast. Maybe not as much precip up here as we were expecting, but we certainly saw mostly snow in these areas, whereas a pretty steep drop-off as you headed east into the Piedmont counties of Virginia and North Carolina, with 2 to 2.5 inches noted there in Danville, maybe 3 inches when you get towards the Martinsville area, and of course much higher as you head west. Ice was certainly an issue, especially out east. Anywhere along and east of the Blue Ridge Mountains saw at least a 1/10 of an inch, but even up to a 1/4 inch of ice, which had certainly some significant impacts when it came to power outages, and we'll get to that in the next slide. But looking here, you actually see a nice close-up view. See the clothespins here. Here's a clothesline out of northwest Stokes County in North Carolina of some good ice accretion there, and they certainly saw much more of it than we did here in Blacksburg. But the reports down this way are actually sometimes spotty, so we certainly needed a good communication tool to try to fill in some of the gaps down there. But thanks to Grant Wise for sending this in. So let's go over some of the impacts. This was certainly a multi-hazard event. We had power outages near 47,000 in parts of southwest Virginia, just about 1,800 in the not as hard hit with the ice, at least, portions of southeast West Virginia, and nearly 35 or over 35,000 without power in northwest North Carolina. And these are just in our forecast area. So you can imagine some of the harder hit areas saw much more than this. Some of the impacts on our staffing, getting to work was a concern for a lot of people. Those with four-wheel drives actually volunteered to pick some of our staff up, and some decided that worst-case scenario, they could stay over. Luckily, the impacts weren't too bad that we needed that, but they were certainly prepared to do so. The workload chunk really increased. We had a lot of travel concerns across parts of the Department of Transportation in our forecast area. Several statewide conference calls throughout the event, including pre, during, and post. School calls and briefings as applicable. As we mentioned, this was a holiday weekend. A lot of people were off of school that Monday. However, around here, an event of this magnitude, especially with cold air working in behind it, you saw school outages up to a week after this event, and that certainly wasn't uncommon for us in this instance. One of the very well-received items that we've started to produce, this was actually created, this is an onset image that was created from a modified script from the Pittsburgh WFO. It basically uses the weather grid, snow totals, and pops that are greater than 50 to determine the onset times for snow and sleet. And this was a very well-received item on both our social media accounts and through our emergency managers and other core partners. Just getting to know exactly when those impacts were going to be felt was very helpful, and this really correlated well with things really started to get pretty rough in these areas. MPing, as we saw in a couple slides ago, was very useful, using that citizen science to understand the ground truth of what was going on, being able to compare that ground truthing to base reflectivity, dual pole radar, incoming social media reports to verify that they're accurate or maybe need to be remeasured. Unfortunately, this isn't very widely used right now in our forecast area, likely due to the lower population compared to some of these high populated areas to our south. However, realizing that this has now become one of our key outreach activities. We want to really try to push the MPing app and getting some of those citizen science data, whether it's MPing or CoCoRaHS, into our system so we're able to ground truth with some of these new technologies. Dual pole radar, I mentioned this a few times, was very helpful, especially comparing it to radar trends, trying to use the CC and DDR to identify the freezing level and the precipitation type changes was highly used and widely used by our forecasters during the meat of the event. And social media really emerged as a vital tool both in the preparation of the event and real-time data gathering. Our office is very active on the YouTube platform for briefings, especially prior to the event. Both Facebook and Twitter have seen an influx in followers, especially in the use of collection of snowfall and ice reports. Those come in on social media, phone, email, and across most of our accounts, and that is one of the widely used ways of getting those reports into the office. So I just want to step through a couple of the examples on Twitter. Obviously, the other platforms were very active, but they didn't really correlate well to the slides. So I just used some of our Twitter grabs, and they were very helpful in getting out the watch, warning, and advisory issuances and updates as we go through. Also, the how-tos. What are we looking for? How should you measure the ice accretion on a branch? Those were very widely accepted and very helpful to those who we were looking to get reports from, and we wanted the most accurate reports as they were coming in. We dove into the science a little bit. We had questions on why parts east were getting sleet, but we were stuck in snow. Well, a look at two soundings, one from Roanoke and one from Greensboro, was easy to see that warm nose had finally penetrated in Greensboro, but had yet stayed well below freezing here in Blacksburg. So that was very widely used. Was a very widely shared post there. We had some intricacies of the event, like, all right, where's the wedge? How is it eroding? Which areas are seeing above freezing temperatures where the other ones might not be seeing that as the next wave of precip comes through? Going over the progression, who's still under a warning? Who has been lifted? Why has it been lifted? The temperature is now above freezing. It's important to really disseminate that information so people understand, and that's one thing that we're seeing the trends on social media is people want to dive deeper. They don't want to just be told what to do and how to react. Some of the unique portions of the event, a QLCS formation that resulted in wind damage to the southern parts of the counties. You wouldn't necessarily think of seeing something like that, and when it actually appears, it's a surprise to the forecasters sometimes, but also certainly a surprise to the users on our social media platforms. some post-event analyses, where how much snow fell in your area, and then obviously some continuous updates on the post-event impacts, especially when it came to river flooding, which is delayed when it came to the snow melt combining with some of the runoff, the forecast of the river stages, and things of that nature. And one of the big feedbacks that we got from our core partners like emergency managers is when they're away from the office during a holiday weekend, they rely on our social media reports. They don't necessarily have the time to go through their emails. So instead, they'll turn their Twitter app on and follow along with our updates and use those updates to necessarily prepare for the proper action. So that was one of the surprise things that came across when it came to this event. And the other big thing that really helped us succeed in issuing the proper forecast and maintaining the proper workload is the staffing. In an event where a lot of the managers are off on holiday leave or annual leave surrounding a holiday weekend, it's very important that we have the proper staffing. And this spreadsheet that lead forecaster of ours made up really came in handy. And honestly, its use is rather simple. It has two main aspects. You have the set schedule, which is denoted in green. That's who's on shift, who's scheduled to be here. This is where you want to look to make sure you have the proper staffing in place. Then you have the availability portion of the schedule. Who's available during these times? You'll see the parentheses here, and those are people that have gone in and said, "Look, I can work during these time frames. If you need me, know I'm available and ready to go." So let's do a quick role play here. The lead comes across and says, "Wow, we're going to have some nightmares when it comes to this 6 to 12Z task period. With only 2 people on shift and all this stuff coming into play, who can we get in here that is experienced with tasks and ready to go?" Well, he looks across and notices that Frank Beamer, who you might have seen it, just put his availability into the extra schedule. He's available. So the 2 options we have are James Morrow, that's me, or Frank Beamer over here, who also is available. He's a lead forecaster, very skilled and very experienced. Well, James might not be the best option. He isn't totally into the whole precipitation type changes yet. So let's call up Frank and put him down. You give him a call. Frank's already available. You know that from the spreadsheet. Boom, he's in there. It takes a lot less time trying to sort through everybody in the office, go down the calling list, try to figure out who you have available. It's all right here, and it's a load off of the lead's back, at least in this circumstance. I also want to highlight one of the unique parts of our office. We have a very close relationship with Virginia Tech and the Virginia Tech Meteorology Program, and we have student volunteers that come in on a regular basis, once a week or twice a week, depending on the role they're playing. And those were actually available during this event. So as you can see, JP was available, and she was actually already scheduled to come in during this event. And those students are very helpful in situations like this where you need to have someone going through the reports, gathering them, getting the PNSs and everything into eClaires and the other technologies that we use. So just a quick summary. This was certainly a complex event, multifaceted. The pre-event staffing spreadsheet really came into use and was great to have, especially when it came to the lead trying to sort through, do I have proper staffing, who's available in a complex holiday weekend. The emergence of social media, it was a very valuable tool, and it enhanced our ability to share and receive information, able to share those infographics, the expected impacts, and get word out to those who may not have the usual way of getting their information. The use of different tools such as MPing, Dual Poll, other citizen scientist type data was very helpful, especially when it came to comparing, what are we seeing on our radar and some of our other remote sensing techniques. The forecast onset image was very highly used and enjoyed by a lot of our core partners. And of course, the special 18Z soundings at Blacksburg and GSO were very helpful, and they really were perfectly timed to see that changeover from, in Greensboro's circumstance, from a sleet to freezing rain type sounding versus in Blacksburg, a snow to sleet type transition. So they were very helpful and well timed there. And of course, one thing that we're starting new in 2017 is the probability of Prob Snow initiative. We didn't have this during this event, but with the things that we're going through now, we certainly wish we did, because the amount of uncertainty would have been easily explained with that type of technology. So we look forward to implementing ProbSnow and starting to get those graphics out here this month or early next month. Well, with that, thanks for sitting in. Steve and I would be happy to answer any questions you may have.